Ice, frozen water, good in summer beverages, but bad on airplanes. As a student pilot, you'll be flying in VFR weather, but there are still instances where you might encounter ice. So here's a look at the potential problems structural ice can cause you. First of all, what causes structural ice to form? Well, for ice to form on any airplane, the airplane must be in visible moisture, period. And visible moisture comes in many forms. It could be clouds. Structural icing is indeed possible from flying inside a cloud if the temperature's right. Of course, what you're doing inside a cloud without an instrument rating is a matter for you and your confessor to discuss. But visible moisture can also take other forms. Snow and freezing rain are two. As you remember from our discussion about warm fronts, the warm air behind the front rises as it moves over a colder air mass. Well, if the air behind that warm front has a lot of moisture in it, as it rises, you could get rain. As that rain falls into the colder air below, it forms a layer of freezing rain. And as it continues to fall through that cold air, it freezes even more, becoming ice pellets. So let's assume you're hanging out at the airport and you see ice pellets bouncing down and around the ramp. Well, what are those ice pellets telling you? They're telling you that there's warmer air at a higher altitude and that there's freezing rain at that higher altitude. And as the freezing rain fell, it lingered in the cold air long enough to change into ice pellets, which means you really don't want to leave on that solo cross country because freezing rain is real dangerous. So what happens to your aircraft? Well, in freezing rain, you have the greatest accumulation of aircraft structural ice. Now, structural ice adds weight in all the wrong places, and it can affect the center of gravity. It also decreases lift on the airfoil by changing its shape. This results in less lift from the wing. And don't forget, your prop is in airfoil too, so you get less thrust as well. Ice protruding from the airfoil also causes form drag, which detracts from the airplane's performance. And sometimes ice is forming where you can't see it. In other words, ice on an airplane, in anything but a drink cart, has no redeeming social value. What should you do if you start to encounter structural ice? Well, it would be wise to develop an alternative course of action immediately. You may want to climb to a different altitude, or you may want to descend. If you climb, you may get out of the icing conditions by reaching colder air where the moisture is solid. Therefore, it won't stick to your aircraft. Or you may be able to descend to a warmer altitude below the freezing level where you won't be picking up ice. But you may not be able to do either of those. So you may need to make a 180-degree turn. But whatever you do, don't sit there letting the ice build up, because you can accumulate a big amount very quickly. Now let's talk about frost. As you remember, frost forms when the temperature of the collecting surface, the aircraft in our case, is at or below the dew point of the air and the dew point is below freezing. That's a key point, the dew point being below freezing, because if the dew point is above freezing, the moisture in the air will change to the liquid state instead and form dew instead of frost. Now, frost can really impact the flight characteristics of your airplane. It disrupts the airflow, raises your stalling speed, and it may prevent the airplane from becoming airborne at its normal takeoff speed. So you want to make sure that you get rid of it before you go flying. Don't be fooled by the fact that there's only a little frost on the airplane. Remove it or regret it. So as far as your flying is concerned, the only good ice is in your soda. And if you're buying, make mine a sarsaparilla.